Hi, my name is Alex Macknow, and I'm delighted to welcome you to this lesson, Lesson 5.2, in which we begin our exploration of the Kaplan method for science questions. Specifically, we'll dissect the first two steps, the assess and plan step. Being in Chapter 5, the underlying skill for this lesson is MCAT expertise. You know, many students who come to prep with us at Kaplan are concerned that they're not good test takers. Well, good test taking for most is not an innate skill, but rather a learned skill that you'll continue to hone through the rest of your studies leading up to test day. Good test takers recognize that the exam is not only a test of your science content knowledge and critical thinking skills, but also your ability to efficiently navigate through the exam, recognizing when and how to work on the various passages and when and how to work on each of the questions. The Kaplan method for science questions will be indispensable to your success on test day. You'll see 177 science questions, and having a practiced but adaptable approach to work through each of them will allow you to rack up points quickly and, ultimately, to show medical schools that you can think linearly and logically like a physician. Again, our focus in this lesson is on the first two steps of the Kaplan method for science questions. So we'll start by investigating how one assesses a question. That is, what the characteristics are of the question stem and its answer choices that help us to determine the difficulty of that question and the relevant science topic that we're being asked about. We'll also look at some of the common patterns for question stems and their answer choices that may inform these decisions. Once we've assessed some of these question stems, we'll use that information to come up with a plan. We'll determine what the appropriate first and following steps are to get from where we are to actually answering that question. Our science topics in this lesson follow an important story in molecular biology, namely the production of a protein from DNA. DNA must be transcribed, and this transcript then processed to form mRNA, which can then leave the nucleus and travel to a ribosome where it's translated to a functional protein using a number of enzymes. While we'll be highlighting some of the salient points about these science topics, the focus of this lesson is not on the teaching of all of this science content, that's covered elsewhere in your Kaplan resources, but rather using them as a launching off point to explore the Kaplan method for science questions. So let's take a look at that method. The Kaplan method is composed of 4 steps. In the first step, we assess the question by looking at the question stem and its answer choices. At the end of the assess step, we should be able to make a binary decision. Is this a question we're going to tackle now, or is it one to skip and attack later? Once we've assessed the question, we'll plan our attack. This is the step where we decide the appropriate first step and subsequent steps after that. The last 2 steps, execute and answer, we won't see too much of in this lesson, but not to worry. Lesson 5.3, which you'll probably watch right after this one, covers those 2 steps in great detail. The Kaplan methods are rooted in learning science, which tells us that this isn't really groundbreaking research. This is how most people problem solve as it is. When you're presented with a problem, you usually assess the situation, see what's going on, come up with an appropriate plan to be able to deal with that problem, and then carry out that plan or execute that plan. Of course, on the exam, you'll also have to choose an answer by clicking on the bubbles next to the answer choices. To be sure, this is also similar to how you'll deal with patients. When a patient comes in with a group of presenting symptoms, you'll assess the patient by doing a history and physical, come up with an appropriate treatment plan in tandem with that patient, and then carry out that plan or execute that plan. Of course, patients don't come with standardized test bubbles, but the rest of the analogy still holds. The benefit, then, of breaking down this cognitive process into 4 discrete steps is twofold. On the front end, it will allow us to identify specific strategies to improve each step of the process, thus making you a more efficient and accurate test taker. On the back end, it also serves as a good diagnostic tool. When reviewing your exams, continue breaking down the questions into 4 discrete steps, and identify if there's a particular step that seems to give you trouble. Are there patterns to your test-taking pathologies? By identifying those specific pathologies, you'll be able to match an appropriate treatment plan, that is a particular type of practice, to that pathology and continue improving your score towards test day. Our first learning goal then is to learn how to assess questions. For each of the 9 questions that follow in this section, we'll identify the relevant science topic we're being asked about and gauge how easy or difficult that question would be for you to answer. We'll also identify some common patterns for question stems and answer choices that may influence that decision of whether I should answer this question now or later. Our goal then is not to answer these questions, and indeed we won't answer most of them, but rather to do good quality assessments of the questions so that we can start mastering the first step of the Kaplan method for science questions. Let's explore the first question. Take a moment to read through this question stem and its answer choices and determine the relevant science topic we're being asked about. There are a few common patterns we see in this question stem. First of all, there's a buzzword given directly in the question stem, DNA synthesis, that gives us a hint as to the relevant science topic. And to tip the hand a bit, most of the questions in this section will be focusing again on that story of molecular biology, from DNA to RNA to functional protein. But notice a few other things. For this question, the difficulty is most likely determined by your content knowledge of DNA synthesis. If this is a topic you feel very comfortable with, this may be a breeze of a question, and it's quick to answer and keep moving through the test. On the other hand, if you don't feel as comfortable with the process of DNA synthesis, this may be a more difficult question and one that should be skipped and returned to later. There are a few other things to notice. We're given a very common phrase for the MCAT at the beginning of this question stem: which of the following is true? This is a relatively straightforward question stem in terms of its wording. We're essentially looking for a true statement about DNA synthesis, and this is a very common pattern to see on test day. So our important takeaways for this question are that we're being tested on cell biology and DNA synthesis, and the difficulty of the question is really determined by our content knowledge within those categories. But we're also given a very common setup for a question, a which of the following is true type question. Let's contrast that first question with this one. Take a moment again to read through the question stem and its answer choices and determine the relevant science topic we're being asked about. Like the previous question, we see a number of buzzwords in the question stem. We see DNA strand, and actually the DNA strand is written out in the second line. We see the phrase RNA strand, and they actually call out one of the processes from molecular biology with the word transcribed, which would be, of course, the verb for transcription. When we look at the answer choices, we notice that they're all RNA or DNA sequences. Notice that the difficulty of this question is determined by more than just your content knowledge. In addition to knowing the process of transcription, we also need to have an attention to detail. The fact that the answers are all RNA or DNA sequences means that we need to keep straight the differences between these two molecules. Also, the fact that the answer choices are all written with polarity directly in them, something that's invariably important in molecular biology, means we need to pay attention to the order in which this molecule would be written. So again, for this question, it's a similar topic to the previous one, asking about similar processes but in different ways, but there's an increased level of difficulty because of this necessity of an attention to detail. So what's different about this question? Again, take a moment to read through the question stem and its answer choices and determine the relevant science topic. One of the first things that might stick out with this question stem is its length. This is a relatively long question stem, certainly in comparison to the two that we've seen previously. Also, the answer choices here are all numbers. Now, numbers may or may not indicate a need to do calculations. It really depends what section you're in. In the biochem section, or psych-soc section, it's unlikely that you're going to have to do involved calculations. But in the chem-phys section, it's not unlikely that you're going to have to pull out a formula, plug and chug, and actually get to a mathematical answer. Because this question would likely be from the biochem section, we probably won't have to do much calculation in this question. But looking back at the question stem, we again see some buzzwords that are being called out. We see the phrase isoelectric point, which would indicate that we're going to have a question about amino acids, and specifically the acid-base chemistry of those amino acids. Going back to the length of the question stem, many students assume that a longer question stem is necessarily a more challenging one. While for this question its length certainly does add to its difficulty, there's a lot of detail we need to sift through in that first sentence, a long question stem is not automatically a hard question. It's entirely possible that the AAMC who write the exam could take a relatively straightforward question and mask it with a bunch of filler text. So for this question, the difficulty is determined, again, not only by the difficulty of the content for you and your comfort with amino acids and isoelectric point calculations, but is also somewhat increased by the difficulty of the wording in that first sentence and the fact that we'll have to integrate that information to actually make a determination of the likely isoelectric point for this amino acid. Let's check out question 4. So what's different about this question in comparison to the ones we've seen already? Take a moment to read through this question stem and its answer choices and determine the relevant science topic we're being asked about. Perhaps the most important thing to notice about this question is that it makes reference to a passage, so this must be a passage-based question. The previous 3 questions could be discrete questions, ones unassociated with a passage, or they could be pseudo-discrete questions, ones that sit next to a passage but don't actually require information from the passage to be answered. Also notice that this question is somewhat the reverse of what we saw in question 1. In this case, the science buzzwords are really called out in the answer choices. While the question stem mentions regulation and enzymes, the idea of enzyme regulation is most clearly hinted to us or indicated by the answer choices. So while there are science buzzwords again, notice the location of the science buzzwords in question 4 as compared to the science buzzwords from question 1. Whereas in question 1, the topic was really called out in the question stem. In question 4, the topic is really more clearly called out in the answer choices themselves. The topic here is enzyme regulation, and it's not only your comfort with the topics within enzyme regulation that will determine the difficulty of the question for you, but also the difficulty of the passage associated with this question. While we don't see the passage here, if you found this passage relatively straightforward, and it was easy for you to pick out the author's main points, then this question's probably a bit easier for you and makes sense to answer now. On the other hand, if you found the passage convoluted and it was difficult for you to discern what the author was trying to say, then this is probably a question to skip and instead look for pseudo-discrete questions to answer. Let's continue our assessments with question number 5. Take a moment to read through this question stem and its answer choices and determine the relevant science topic we're being asked about. Like the previous question, we see that this must be a passage-based question. There's a reference to sample C, which must be something they've discussed in the passage. But the answer choices are really the key to this question. Not only do they call out the relevant science topic, we're going to be looking at amino acids, no matter which answer choice we're looking at, but the parallel structure is the important takeaway from this question. It's very common to see answer choices in this form, where essentially it's the same sentence but with certain phrases swapped in or out. This can make this question much easier to answer, and for now, that's the most important thing to notice. But let's take a look ahead and identify the decisions we'd have to make while actually working through this question. In this case, we need to determine if the amino acids are aromatic, as in answer choices A and C, or if they're charged, as in answer choices B and D. That will be one decision, aromatic versus charged. We'll also have to determine if the amino acids are likely to be inside the proteins, as in answer choices A and B, or outside of these proteins, as in answer choices C and D. Again, the parallel structure of the answer choices can make a question like this one much quicker to answer. Ultimately, the process of solving out this question will be making 2 binary decisions. Immediately contrast this question then with question number 6. Take a moment to read through this question stem and its answer choices and determine the relevant science topic we're being asked about. This question must again be passage-based. We see references to prelamin A and progeria, topics we're certainly not expected to have familiarity with walking in on test day. And we see the relevant science topic called out in the answer choices. In this case, we see mutation showing up in quite a number of the answer choices, so we're going to be looking at changes in DNA sequence, mutations, and their effects. But the real takeaway from this question is when we look at the answer choices for this question in comparison to question number 5. Remember that in question number 5, the parallel structure of those answer choices would allow us to make quick work of the question and arrive at a correct answer choice relatively quickly. Savvy test takers will recognize the difference between that question and this one. The question stem on this one is quite a bit longer and more convoluted. The answer choices are also longer and are not written in a way to facilitate answering the question quickly. Indeed, we're going to have to do quite a bit of logical reasoning just to arrive at the correct answer. So this is a question better left skipped on test day. Even if you know the topics of molecular biology cold, and you know that you could get the answer to this question, it's just going to take too much time to get there for it to be worth doing now. You can always come back to questions you've skipped at the end of the passage or at the end of the section, and hopefully by then you'll have built up enough of a time buffer to give these questions the time they really deserve to arrive at the correct answer. Finally, let's assess question 7. Take a moment to read through the question stem and its answer choices, and determine the relevant science topic as well as the relative difficulty for you. This is another passage-based question. We see a reference to paragraph 4 in the question stem, and the relevant science topic is called out in the question stem as well. We see that they're talking about mutations and whether or not they're fatal. But now turn your attention to the answer choices. The MCAT cannot ask a simple yes or no question because they have to provide 4 answer choices. So this is a relatively common pattern to see on test day as well. We'll have to determine if the answer to this question is yes or no, but there are 2 answer choices given for each of those options because we'll then have to associate it with the correct logic. As the Kaplan tip on the bottom of the page points out, these patterns show up time and time again throughout your practice as well as on test day. Because these patterns can have bearing on how difficult the question is to answer, it's important to recognize which patterns are easier or harder for you to answer. That will ultimately play into your decision of whether to answer a question or to skip and come back later. So let's summarize what we've explored thus far with the learning goal before diving into 2 final questions. When assessing a question, make sure to read the question stem and possibly the answer choices. Read the answer choices if they're short or in parallel form, but avoid reading the answer choices in detail if they're long and convoluted. Assessing a question should only take a few seconds, and you're looking for some of the patterns listed below. We won't go through every one of these patterns again, but think of them like the presenting symptoms of a patient. Much like the presenting symptoms of a patient are certain characteristics that could make a situation more or less urgent, easier or harder to treat, so too do these patterns help influence whether you should do a question now or later, the difficulty of that question, and how much it's worth doing that question at that time. The one pattern that we will point out, however, is at the end of this list. In addition to some of the standard patterns that we've pointed out, allow your individual test-taking behavior to influence your assess step. The individual pathologies that you have, common right and wrong answers, areas of opportunity and areas of strength in terms of content, certain patterns that seem to cause you individually more difficulty, these are all things that could have bearing on the decision of whether to do a question now or later. Then, these patterns or presenting symptoms will enable you to discern the science that's being tested, how easy or difficult that question will be for you, and how long the question will take. All of these factors, of course, feeding into that decision, should I skip the question or should I tackle it now? Beyond this binary decision, notice the other ancillary benefits of the assess step. By identifying the science topic, you start recalling knowledge even before you explicitly plan your attack. And that leads to better and faster integration of that science knowledge as you execute your plan. In fact, you might notice that as you practice the assess step, plans start naturally and effortlessly coming to mind to be able to answer the question, and that's a good thing. It's representative of your increasing MCAT expertise. So if you're doing the assess step correctly, how should it feel? Well, it should only take a few seconds, but it should leave you with a wealth of knowledge. First of all, decide if you will be tackling the question now or skipping it and coming back later. And if you are going to be tackling it now, you should be able to answer 3 questions. Where do I look? What am I looking for? And what am I trying to decide? As these will all be important during the plan step, which we'll be investigating momentarily. On the other hand, if you find yourself getting to the end of a question stem and not really knowing what the appropriate next step is, then it's worth spending some time practicing assessing questions. So let's do just that. Let's practice assessing 2 last questions before moving on to our next learning goal. Read through this question stem and its answer choices, and again determine the relevant science topic and its relative difficulty for you. But also notice anything unique to this question that makes it different from the previous ones. The science topic is called out relatively clearly again. We see buzzwords like mutation, and in the answer choices, codons, which imply that we're talking about mutations and their effect on translation. But notice some of the unique factors of this question. The question stem uses the word least, You'll notice that it's capitalized here, and on the MCAT, the word least or except or not or false, those kinds of negative words, are usually, although not always, capitalized in question stems. This is another variation on those which of the following questions, although in this case we're looking for which of the following positions for an altered nucleotide is least likely to lead to an altered final protein. You may have also noticed that this question stem is relatively long with short answer choices. Finally, our last question. Read through the question stem and the answer choices and again determine the relevant science topic and the relative difficulty for you. The science topic is called out in the question stem, although in a bit of a masked way. We see the phrase pepsin activity, pepsin being an enzyme, our topic here will be enzyme activity, and we see in the question stem the word graphs, we also see that in the answer choices. So the question stem mentions the graphs and it's relatively short, but notice something about the graphs that are given in the answer choices. They all have the same axes, and they all have similar shapes. They're all bell curves here. This, in many ways, makes this question similar to some of them that we've seen before, such as question 5, in which we had to compare amino acids based on them being aromatic or charged, inside or outside of proteins. It's similar to question 7, a yes or no question, where 2 answers were yes and 2 answers were no. The similarities between these graphs then allow us to make quick work of this question. We'd have to identify the ideal pH and the ideal temperature for pepsin as an enzyme. Finally, take note of the Kaplan tip on the bottom of your page. The patterns that we're identifying during this learning goal may be relatively straightforward, but the influence that they'll have on the decision of whether or not to attack a question cannot be underscored enough. By recognizing the patterns that commonly are easy questions for you or more difficult ones, you'll be able to get points as quickly as possible on test day and get those scores that you deserve. So we've introduced the idea of assessing questions and worked through a number of examples. Let's move now then to the second step of the Kaplan method for science questions, the plan step. The plan refers to the set of ideas you have before working through and solving an MCAT question, and everyone makes plans, whether conscious or not. But not all plans are created equal, as we'll certainly see from the first 2 examples in this learning goal. Our focus then, during this learning goal, will be helping you to improve and make better plans on test day, those that will enable you to get an accurate answer as quickly and effortlessly as possible. In the Kaplan method, the plan is treated as a separate step from the assess step, but recognize that as your test-taking skills and pattern recognition skills improve, that you may start coming up with plans automatically while assessing a question. And there's nothing wrong with that, it's just making you faster and a better test taker. So with that, let's take a look at a question we've seen before and decide what the most appropriate plan would be to answer that question. Before coming up with plans on our own, let's make sure we can identify good plans and some of the common pitfalls that can occur during the plan-making process. We've seen this question before. It was question number 2 in the previous learning goal, and when we assessed the question, we pointed out that it has a relatively short question stem and that the science that's being called out is the transcription of RNA from DNA. Let's take a look at a few potential plans for this question and discuss the merits or flaws of each. Take a moment to read through this plan and determine what makes it a good or bad plan for answering this question. This is not a great plan for answering this question. Put a big X next to it. This question is a pseudo-discrete or discrete question. It's not going to require information from a passage. Now, that may seem obvious on this question, but it's a common pitfall for many students during the plan-making process, especially if you're not sure what your first step should be. In other words, if you're not sure how to proceed, don't automatically default to scanning the passage looking for relevant text. It may lead you nowhere and is a haphazard way to attack this question. Take a moment to read through this second plan and again, determine what makes it a good or bad plan for answering this question. At an initial glance, this may look like a good way to attack this question, and indeed, if this was a free response test, that would be the appropriate way to proceed. We would have to determine the exact strand of RNA that would be transcribed from this DNA template strand. However, this is a lot of wasted work. Put a big X next to this one as well. Process of elimination will be a much easier way to attack this question than working out the exact transcript that we would get from this DNA strand. Finally, take a look at this third plan, and again determine what makes it a good or not so good plan for answering this question. So this is probably the best way to attack the question, and indeed many of your plans for science questions will look a lot like this. The student is identifying a few relevant facts that he or she knows about DNA and RNA pairing, what occurs during transcription, and rather than working out the exact answer, will use those pieces of information to start doing process of elimination to arrive at the correct answer. Ultimately, many plans again do look like this. The idea is the appropriate way to proceed is to go to the right file folder in your brain that contains the information associated with the topic that's being asked about and pull out those right content associations. Then hit those answer choices. How about this one? We've also seen this question before, and when we assessed it during the previous learning goal, we pointed out the fact that the answer choices are all numerical and the question stem is relatively long. We also noted that the relevant science topic being called out is the isoelectric point for a given amino acid. So let's take a look at 3 potential plans and again assess the flaws and merits of these different plans. Take a moment to read through this first plan and determine what makes it a good or not so good approach for answering this question. This is not a great plan for answering this question. While the student took note of the fact that an amino group is mentioned in the question stem, this is really not useful information for answering the question. This is not a unique characteristic of this amino acid. Indeed, all amino acids have an amino group and a carboxylic acid group for that matter, and will also not help us narrow down to one answer choice. Indeed, 2 of the answer choices given here are in the basic range. Take a moment to read this plan as well and determine what makes it a good or not so good approach for answering this question. This is again not a great plan for answering this question. It's far too much work and wasted knowledge. The MCAT does expect you to be familiar with the structures of the different amino acids, but certainly you are not expected to memorize the isoelectric points for each. Indeed, the amino acid being talked about is probably arginine in this question, but memorizing the PI values for each of the amino acids is outside the scope of what the AAMC expects you to know on test day. Finally, let's look at this third plan and determine what makes it a good or not so good approach for answering this question. This is the way to do it. In longer question stems, some information is usually more useful than other information. Oftentimes, the AAMC will mask some of that important information using filler text or other facts that you're already expected to know from outside knowledge. So this student will go back to the question stem, explore what makes this amino acid unique, and then find an answer that fits that description. To take it that extra step, and this is foreshadowing the execute and answer step a bit, but the question stem describes this amino acid as having an amino group and a carboxyl group, 2 characteristics of every amino acid, optical activity, a characteristic of every amino acid except for glycine, and multiple nitrogen groups. That's the unique characteristic for this amino acid. And with multiple nitrogen groups, we would expect this amino acid to have an isoelectric point, or PI, pretty far into the basic range. Sure, there are 2 answers that fit into the basic range, but 8.05 is not that far from physiological pH. It's less than 1 pH unit away. 11.15, on the other hand, is pretty far into the basic range and is a much better pick for the answer choice to this question. So why is this third plan the best? Well, put simply, the student identified what he or she knew about the question before proceeding with answering it. There are many sources to draw on here. Certainly, the content knowledge the student has is important, but so too are the patterns we identified during the assess step. Remember, those different patterns will affect how easy or difficult a question is to answer, and will also impact the appropriate plan for that question. The student also does not assume too much before hitting the answer choices, but rather stays within the confines of the question stem as it's been stated. The student also uses skill to determine what portions of the question stem are most important, distilling out only those details and using them to create the plan. Finally, the student leverages his or her content knowledge, which will be important for a large number of the questions on the MCAT. While content isn't the main focus of every question, certainly most questions will require you to draw on at least some content knowledge to be able to answer them. As the Kaplan tip on the bottom of your page points out, the plan step is all about answering the question, where have I seen this before? And then transferring that knowledge to the question you're working on. This knowledge can come not only from science content, but also recognizing the individual types of questions and different patterns you've seen during the assess step, and also introspection, knowing which kinds of plans have performed well for you in the past and which ones haven't. So we've now taken a look at some example plans and investigated the merits and flaws of each. Now, let's start coming up with plans on our own. To do this, let's do it in the context of a passage. That will give us the opportunity to see not only passage-based, but also pseudo-discrete questions. Take 5 minutes to read through and outline this passage on your own. Afterwards, I'll point out some of the important features of each paragraph and demonstrate an appropriate Kaplan outline for this passage. If you haven't yet familiarized yourself with Kaplan's passage outlining strategy, which is covered in Lesson 5.1, it may be worth spending some time watching that video before continuing with this passage. But if you're ready, take 5 minutes to read through and outline this passage. So let's work through this passage. I'll highlight some of the key points from each paragraph and put together a Kaplan outline for this passage. Your outline may not be identical, but that's okay. As long as your passage outline helps you distill out the main points of the passage while serving as a key resource to locate answers if you need them in the text, you're doing fine. Starting with the first paragraph, we're introduced to our topic for this passage, which is Hutchinson-Gilford progeria syndrome, or HGPS. This paragraph mostly serves as an introduction, presenting some of the signs and symptoms associated with this disorder. Like many MCAT passages, the first paragraph serves mainly to introduce us to our topic, but doesn't really have a lot of testable information. An appropriate label for this paragraph might be that this is our introduction to HGPS, and that we're given the signs and symptoms of this disorder. In the second paragraph, we're given quite a bit of information about the molecular biology underlying HGPS. We're told that a point mutation occurs in this disorder in the gene for lamin A, and that this point mutation ultimately causes a shortened mRNA transcript to be generated. Once this mRNA transcript goes through translation and moves into post-translational processing, it means that it can no longer lose this farnesyl group, which ultimately causes it to be locked to the nuclear rim. Notice that they give us a new term in this sentence, they've defined it in the previous one, that this mutant prelamin A is called progerin. We're told that this locking of progerin to the nuclear rim means that it can no longer offer the structural support that it needs to the nuclear envelope, and that ultimately this causes a misshapenness to the nuclear envelope, and that down the line it's implied that this causes issues during mitosis. Well, that's a lot of information, so if we distill that down to a short label for our passage outline, we could say that the cause of progeria ultimately is this point mutation causing a shortened mRNA transcript. For the rest of the details, we can always come back to the passage and locate them. For now, this should suffice as an appropriate description for the paragraph, and we'll keep moving forward. So if paragraph 2 focuses on the aberrant molecular biology that occurs during Hutchinson-Gilford progeria syndrome, it should be no surprise that the third paragraph contrasts this with normal prelamin A post-translational modification. We're also told that this happens in 4 steps, so let's trace through these 4 steps one by one. The first step is the farnesylation of a cysteine residue in the protein by an enzyme called farnesyl transferase, or FTase. We're then told in the second step that a small portion at the carboxyl end of this protein is removed. And then, for the third step, that product is methylated. Finally, for our fourth step, a larger portion of the protein is cut off by a peptidase called ZMPSTE24. We're given a reference to a figure, which will be helpful to be able to visually demonstrate what happens during this process, and at the very end of the passage, we're given a quick note that FTase inhibitors appear to reverse some of the malformations illustrated in paragraph 2, and therefore may be a potential therapy for this disorder. There's a lot of information in this paragraph, so again, it's not worth writing all of it down, but an appropriate label for this paragraph would be noting that it's illustrating the process of normal post-translational processing for prelamin A. Finally, we're given 2 figures which illustrate the process of post-translational processing in Hutchinson-Gilford progeria syndrome, or with mutant prelamin A, as well as during the normal process. It's important to note that these figures include almost all of the information from paragraph 3 and quite a bit of the information from paragraph 2 as well. If we need to come back to the passage, these may serve as a quicker source of information than reading through all of the text. While labels are provided for the figures on the MCAT, it's still important to put labels into your outline for each passage element. So, for the first figure, we might note that this is HGPS post-translational processing, whereas for the second figure, it's focused on normal post-translational processing. Now that we've worked through the passage, let's turn our attention to the questions. So now, let's have you start coming up with plans on your own. You'll see, for the questions associated with this passage, the answer choices are all grayed out for now, because during the plan step, the focus should be on the patterns of the question stem that you've identified during the assess step. For each of these questions, we'll give you a moment to jot down what your plan would be for answering this question, and then I'll walk through how an expert test taker would assess and plan to answer this question. Let's start out with question number 10. Take a moment to read through this question stem and come up with what your plan would be for attacking this question. During the assess step, we should have noticed that the answer choices are relatively long logic-based answers, and that the science topic called out in the question stem are these FTase inhibitors, which are also mentioned in the passage. Therefore, an appropriate plan for this question will require us to go back to the passage to find out what FTase does. FTase, or farnesyltransferase, is talked about in a few places in the passage, and we will have to determine what happens if this enzyme is inhibited. Because the question stem mentions the malformation of the nuclear envelope and its reversal when FTase inhibitors are used, it makes more sense to look at the function of FTase within the context of progeria rather than its normal function, and we have a few places where we could look for this information. Paragraph 2 highlighted the molecular biology of progeria, but Figure 1 is probably the most helpful here. Figure 1 provides a visual example of the post-translational processing that occurs in Hutchinson-Gilford progeria, and may give us a good opportunity to see what happens if FTase is inhibited. We'll stop there for now. On test day, you would of course continue to the execute and answer step, both of which are covered in Lesson 5.3. In fact, we'll come back to this passage and its questions in Lesson 5.3 to do just that. So if you're chomping at the bit to keep moving forward and execute the plan and choose an answer to this question, that's great. Keep watching the rest of this lesson and move on to Lesson 5.3, where we can see the payoff of the plan step. What about this question? Take a moment to read through the question stem and determine what your plan would be for answering this question. During the assess step, we may know that the answer choices are all very short, they're just names of amino acids, and that the question stem is asking us for an amino acid found at the carboxyl terminus of prelamin A. Well, prelamin A is certainly not a protein we're expected to know the primary structure for by heart, so we're going to have to go back to the passage. In particular, it makes most sense to go back to paragraph 3 for this question. Normal post-translational processing is discussed in this paragraph, and the structure of normal prelamin A is discussed in most detail there. When we go back to the passage, we'll be looking for descriptors of amino acids, perhaps charged or uncharged, acidic or basic, or, in fact, as we'll see during the execute step, these amino acids are described as being aliphatic. Let's check out question 12. Take a moment to read through the question stem and determine what your plan would be for answering this question. We've actually seen this question before, and during the first learning goal, skipped it as question 6, pointing out the fact that it has these long logic-based answer choices that all focus on mutations. But now that we're actually creating our plan for this question, let's determine what the next appropriate step would be. The question stem calls out faulty prelamin A, which should be a dead giveaway that we do need to go back to the passage, and in particular, we need to go back to paragraph 2. Once we get there, because they're asking for what causes the production of this faulty protein, we should determine what the molecular biology was, what the mutation was that exists in Hutchinson-Gilford progeria syndrome, and how that causes progeria. All three of the questions we've seen thus far for this passage have required us to go back to the passage text. But as the Kaplan tip on the bottom of your page points out, there are actually 3 sources of information from which we could draw once we move into the execute step. So during the plan step, an important decision will be determining where we'll go for the information. Do we go back to the passage? Do we go back to our passage outline? Or do we go back to our mind, the science knowledge and critical reasoning skills that we've honed throughout our studies for the MCAT? Oftentimes, questions will ask us to hybridize these different sources, utilizing a combination of information to answer the question. Let's move on to question 13. Take a moment to read through this question stem and determine what your plan would be for answering this question. During the assess step, we note that many of the answer choices have buzzwords in them that remind us of terms from the passage. In addition, the question stem mentions the stunted growth and musculoskeletal degeneration that is characteristic of Hutchinson-Gilford progeria syndrome as described in the first paragraph. For this question, an expert test taker may have a bit more broad of a plan. In this case, the question's really asking about the causes and features of progeria, and it's appropriate to use a combination of the passage, our passage outline, as well as our mind to remove any choices that are not associated with progeria. The answer choice we would be looking for is something associated with progeria, so it makes sense that the other answer choices are going to be normal characteristics or characteristics that are just not associated with this disease. Finally, let's move on to the last question. Take a moment to read through this question stem and determine what your plan would be for answering this question. When assessing a question, we may note that it's a relatively short question stem and that the answer choices all include buzzwords associated with DNA structure and base pairing. The mutation mentioned in the question stem is the same one that occurs in Hutchinson-Gilford progeria syndrome, but going back to the passage here would be a trap. This is a pseudo-discrete question, one that sits next to a passage and uses some content that is related to the passage, but does not actually require us to gather information from the passage to answer it. In this case, the most appropriate plan would be to consider the differences between cytosine and thymine, in particular differences in their structure, their base pairing, and classification, and then use process of elimination to narrow it down to the correct answer choice that describes the changes that would occur when cytosine is replaced with a thymine. As the Kaplan tip on the bottom of the page points out, this is indeed an example of a pseudo-discrete question, and pseudo-discrete questions are not a rarity on the MCAT. Most passages will have one or two pseudo-discrete questions associated with them. Why do passages have pseudo-discrete questions? Well, one of the skills the AAMC wants to assess is not only your ability to use information when it's available to you, but also to recognize when that information is actually useful. This is a similar skill to one that you'll use as a physician, recognizing when information is or is not important to a diagnosis, recognizing when an aberrant lab value is or is not significant. What this means is that your plan should not automatically be to go back to the passage anytime you have a passage-based question, but to discern when information from the passage is actually necessary to answer the question. Congratulations, you made it to the end of this lesson. Before we finish, let's take a moment to review the key features of the assess and plan steps. During the assess step, we take a few seconds to read through the question stem and glance at the answer choices and look for a few key patterns. Things like important science buzzwords or references to a passage in particular if it's a passage-based question, how long the question stem and its answer choices are, any numbers or formulas, keeping in mind the section that we're in to determine if we'll have to do calculations or not, and other common patterns, things like yes or no questions, other answer choices written in parallel form, or long logic-based answer choices. At that point, we try to determine what the relevant science topic is that's being asked about, we gauge the difficulty of the question, and we determine how long it would take to answer the question. All of these factors, of course, playing into that decision of whether or not to triage the question. Is this a question to attack now, or is it one to skip and come back to later? While it's not mentioned specifically on this list, remember the importance of previous questions on your decisions during the assess step. Looking for patterns for questions that you know that you individually perform better or not so well on will also play a role in determining if you will attack a question now or come back to it later. During the plan step, we use information that we've gleaned from the assess step to determine what the appropriate first step and subsequent steps are to answer the question. Again, use previous questions that you've seen to avoid common test day pathologies that you may have. And while we didn't discuss it specifically in this lesson, it's important to recognize that the plan needs to be adaptable. If you begin to solve a question and come across or remember new information, it's important to be able to change gears to improve the plan if you need to. Similarly, if the question ends up being significantly harder than you originally thought, it's acceptable to still stop working on that question and come back to it at a later time. If a question is going to take many more minutes than you originally expected, similarly, it makes sense to skip that question and come back to it at a later time. Even if you've started solving through that question, the time saved from stopping at that point, choosing an answer choice, and then moving on will be well worth it if you're able to answer a number of other questions correctly in the time it would take you to answer just this one question. Remember, the plan is all about making sure that you're thinking in the right way before you start solving, so that you're not haphazard and disorganized on test day. Yes, it does take some time up front to come up with a plan, but that time is well worth it because it speeds up the rest of the question answering process and makes it much easier to work through the answer choices. Congratulations on making it all the way to the end of this lesson, but the assess and plan steps are only half of the story. In Lesson 5.3, we'll dissect the other half of the Kaplan method for science questions, the execute and answer steps. Thanks for watching, and good luck on your exam.